So there's a lot more to dividing polynomials than the add, subtract, and multiply, as you'll see. So a couple things about, this is part of the SOLs. If I look at that last objective there, it's all about understanding relationships between what we call a linear factor and zeros or roots or x-intercepts. All those things are kind of the same. But how do those relate to linear factors? So I want to, before we start this, we look at what is a linear factor. Okay. What does it mean to be linear? It means x is to the first power. So linear factor is something like this: 2x plus 1, 3x minus 4. The x is to the first power. That's what makes it linear. Yeah, if you graph y equals 2x plus 1, it'd be a straight line. But we're not talking about the graphs now. We're just talking about the power of x. Now, what I'm going to call a simple linear factor is when the coefficient of x is 1. So something like x plus 1 or x minus 4. Right? That's just like I called a simple quadratic was when the a was 1. So this is a simple linear factor. And it makes a difference in what we're doing today a little bit. Good. Ready, Sydney? Okay. So the relationship between, remember, roots are what you call it when you're solving an equation, right? The roots of the equation are the solutions. If it's a function, it's called zeros. And if it's a graph, x-intercepts, if it's a real number. So notice that if the root or the 0 or the x-intercept is 3, that means that there is a linear factor, which is x minus 3. Right? Because what do I get if I plug in 3 for x there? 0. 3 minus 3, 0. Right? If this is a negative number, if the 0 is negative 2, then the linear factor is x plus 2. Right? Because negative 2 plus 2 is 0. Or another way to think of it is x minus negative 2. If the 0 or root is 1/2, then the linear factor can be x minus 1/2. Because what do you get if you plug in 1/2 for x here? 1/2 minus 1/2, 0. But if I multiplied both of those by 2, like that, so that it had integer coefficients, what's the 0 of that? It's still 1/2, right? So if something calls for integer coefficients, you're not going to say x minus half. It's going to be 2x minus 1. But it's still the same 0. So the relationship between zeros and linear factors. The linear factor is x minus the 0. That's an SOL. That's one of our standards of learning. Good. Okay. So we're not going to solve this. Not yet. But what we're going to do is just to kind of motivate, well, why do we divide polynomials? What's the purpose of it? Well, if I'm looking at that problem, and at this point, what methods do I have to solve factoring? That's what we did in the last lesson. Because it has 4 terms, you might think, well, maybe if I group the first 2 and the last 2, then it'll be factorable. But does that one look like it would simplify? Remember that those were always cubic polynomials, where when you group the first two and the last two, you kind of notice they had a pattern to them, right? But this doesn't really have any pattern. 12, negative 20, negative 7, 15. I can group them. There might be a common factor there, certainly 2x squared or 4x squared here, but it's not going to leave the same thing in parentheses, so I wouldn't be able to factor any further. So we don't have a way to factor something like this yet, but there are ways to do it. If you know what one of the zeros is, which means you know what one of the linear factors is, then you can simplify it by dividing out that linear factor. And I'm going to tell you, the question may be, well, how do you know this? We do a little bit more in the next lesson of how do I know x minus 1 is actually a factor of that polynomial. But it is. So what I know is x minus 1 times some polynomial equals the polynomial that I'm trying to factor. I need to know, how can I figure out what goes in that set of parentheses? What's the polynomial? Which, if I divide both sides by the x minus 1, what it's saying is, if I want to know what that polynomial is, I've got to divide that one, the numerator, or the dividend, by the denominator, or the divisor. So we need a method that would allow us to divide this by this. Now, when you divide polynomials, you are always, the numerator has a higher degree than the denominator. Okay, we're never dividing with the denominator having a higher power in it. It's always the numerator has the highest power in it. Okay, so we're going to learn two methods for dividing. One of them always works. It's called polynomial long division. And it works just like long division. The other one is called synthetic division, which sounds scary, but when you're done looking at them both, you'll probably prefer it. If you have like a choice to use one or the other, you'll probably choose synthetic division every time. Okay, so polynomial long division. You know, I noticed more in this textbook than in other books that I've used before, that they really tried to make the adding and subtracting and multiplying look like you were just doing it like you do it with numbers, right? Especially in their vertical format. You know, they had always everything lined up. You know, they made it almost like had place value and everything. Well, polynomial long division also, it works pretty much like long division does with numbers. But, you know, normally if I was dividing with long division, I'm going to say to myself, how many times does what's outside divide into what's inside? Kind of similar to that. What I'm going to ask is, and I'm only looking at the leftmost term, inside and outside. I'm going to ask myself, I mean, in a way I'm saying, how many times does x go into 12x to the third? But just think of it. What would you multiply times x to get 12x to the third? 12x squared, right? So that's what goes on top, 12x squared. Right? So just think to yourself, what is it that I multiply times the x, the first term on the outside, to get 12x to the third, the first term on the inside? Now, once I've picked that out, 12x squared, now I need to multiply, just like we did with long division. I need to multiply times the x, and I need to multiply times the minus 1. Distribute. Right? The 12x squared times x will be 12x to the third. The 12x squared times negative 1 is minus 12x squared. Okay. Now, if you were doing long division, what would you usually do at this point? Subtract, right? So we're going to do the same thing. We're going to draw ourselves a bar, and then I'm going to subtract. Okay, now when I subtract, I'm subtracting a polynomial with more than one term. So I've got to be careful about the signs. I mean, it's by far what we make the most mistakes on when we do this. So starting here, right, with the 20x squared, what is negative 20x x squared minus negative 12x squared. Negative 20 minus negative 12. What is it? Negative 8, right? Negative 20 minus negative 12 is like negative 20 plus 12, negative 8. Okay, now the 12x to the third, if I go to the left of that, 12x to the third minus 12x to the third cancels, because that's how we picked, what we put up on top first, right? So that should happen. Okay, what do you normally do in long division at this point? You've done your subtraction, but you're not done yet. What do you do next? You bring down digits, right? And here we're going to bring down the next term, minus 7x. Okay, then we're going to repeat the process. Get rid of this. All right, repeat the process. What would you multiply times x to get negative 8x squared? Negative 8x, right? So if I put in a minus 8x up here, and then what do I do with that? Distribute it to the divisor, right? To x minus 1. So negative 8x times x is negative 8x squared. Negative 8x times negative 1 is plus 8x. And again, what do we do at that point? We subtract. All right, what's negative 7x minus 8x? Negative 7 minus 8. Negative 15, right? Coefficient will be negative 15 and it's still an x. So negative 15x. Okay, bring down the plus 15. Okay, last, what do you multiply times x to get negative 15x? Negative 15. Okay, and now distribute. Negative 15 times x is negative 15x. Negative 15 times negative 1 is plus 15. Subtract. What do I get? 15 minus 15, negative 15x minus negative 15x, 0. What did it mean when you did long division? You got a remainder of 0. Ian? Okay. You're done? What? It means the thing you were dividing by was a factor of the thing you were dividing. The divisor was a factor of the dividend. That's what it meant. So this here means x minus 1 is a factor. Right, so 12x squared minus 8x minus 15. So we know what goes in here now. 12x squared minus 8x minus 15. 12x squared minus 8x minus 15. Now, the truth is that a lot of times once you've factored out that first 0 or the first factor, what's left in the parentheses, that's factorable. I mean, in this case, since a does not equal 1, 12 times negative 15 is negative 180. Are there factors of negative 180 that add up to negative 8? How about negative 18, positive 10? 10 times negative 18. So in fact, we could go through that 4-step process or so and keep factoring, which is normally what you do. Usually you have to find one 0, and then you divide it out so that you get a lower degree polynomial. If you're starting with a cubic, then after one step you've got a quadratic. And you can finish off a quadratic by quadratic formula or factoring, whichever way you can. If it starts out with a higher power, like x to the 5th or x to the 4th, you try to keep going until you get it to a quadratic. because you can always finish with the quadratic formula. So that's polynomial long division. So I'm going to do the one on the left. I'm going to repeat the steps and show it, and then you're going to try to do the one on the right. Okay. So again, let me move this a little bit because I didn't leave myself much room. Okay, on the first one, what do I multiply times x, that's this one right there, to get x to the third? X squared. So that's what goes on top, x squared. Then what? Distribute. X squared times x is x to the third. X squared times negative 4 is minus 4x squared. Subtract. What is negative 6x squared minus negative 4x squared? Yeah, negative 6 minus negative 4 is like negative 6 plus 4, which is negative 2x squared. Right? Bring down to 5x. Okay, now what do I multiply times x to get negative 2x squared? Minus 2x. Right? Distribute. Negative 2x times x is negative 2x squared. Negative 2x times negative 4 plus 8x. Subtract. What is 5x minus 8x? Say again? Negative 3x. Okay, bring down the plus 12. Right, what do I multiply times x to get negative 3x? Minus 3. And negative 3 times x is negative 3x. Negative 3 times negative 4 is 12. Subtract. 0. So what does that tell me? That x minus 4 is a factor. Right? And then x squared minus 2x minus 3, that's an easy factor too, right? X minus 3 times x plus 1. Right, so what are the zeros? 4, 3, negative 1. So try to do the one on the right. Try to repeat those kind of steps and see whether we can get the one on the right. So you can see the work that should have been there. But I tell you that the place where we always make the mistake is right here. Right? If not right here, then right here. You know, it's going to be one of those places when you do the subtract. Now, I didn't write it, which I should, to be consistent, but you know, these are all subtracts. Okay. If you're gonna like change that into an addition, that's up to you. I mean, we saw when the book did a subtraction of polynomials, they did kind of turn it into an addition. I've never seen people try to do that within the long division. But one way or the other, you need to get that arithmetic right. And then you can see x squared plus 3x minus 10, that's factored in. Is that a question? Okay, keep it to this.
So we're that part of 3x squared minus 22x. It's going to sound how it's done, but so the 4 goes into the 22, or they both, can you explain that part?
Taylor, you have a math question? You want to move to the other side of the room? Okay, I'm getting tired of it. Go ahead.
Might be how you explain that part again, how you get the 3 and the 7.
Yeah?
No, up on the...
There?
Yeah. Like how is that?
Well, once you've got this here, now you've got to compare that x to that 3x squared. So what would I multiply times x to get 3x squared? 3x. That's how I get 3x. Yeah.
Okay, so the bottom, I know that you got x minus 4 because of the, okay, at the bottom where you get the x minus 4 and the x plus 5 and the x minus 2, how did you get
You say it again. Put it in here.
that the bottom, the x minus 4, like the answers, how did you get those?
Well, I mean, the x minus 4 is that x minus 4. That x squared plus 3x minus 10, that factors as x plus 5 times x minus 2. I just factored them on
So the
step.
answer is from the top.
Yeah.
Okay.
I mean, if you get a problem that says, divide this by this, then, you know, all you have to do is get the answer on the top. If it says completely factor, then you need to keep going. But, I mean, I chose these because they were actually factorable. That's why I chose them. Okay, let's see. Okay, now, synthetic division. This is the same problem we started with. But we're going to use a different method, which is called synthetic division. Now, if you look at the original problem up here, and then you look at what I have set up to do synthetic division with, you should kind of be able to see, like, where did I get the numbers that I put in there? And where did I get these numbers right here? What are those called? Variables. What are those? The coefficients, right? So take the coefficients of the dividend, which are dividing, right? And write them in a row right there. And then put a square bracket, or in some way you put off to the side. In this case, I put a 1. Where do you think the 1 came from? I mean, we were dividing by x minus 1. So where do you think the 1 came from? But it wasn't negative 1. I mean, we were dividing by x minus 1, but I put positive 1. Because what am I really putting there? The 0. Not the coefficient, the 0. What is it that I would plug in for x to make this equal to 0? 1, positive 1. So whatever you're dividing by, I mean, if that's a negative, then that's a positive. If that's a positive, then that's a negative. Just keep that straight. Okay, then I draw myself a line where I'm leaving a space, because I know I'm going to be writing some numbers in there. And I bring this 12 below the line. Whatever that number is, bring it below the line to get started. In fact, it's not a bad idea at that step to even like draw an arrow showing that you're putting it there. Because I've seen mistakes made before where students try to put numbers there. And you're going to have trouble if you do that. Okay, now at this point, everything is all lined up. Right? These are the steps to do synthetic division. Right? You multiply the 1 times 12. Right? That's a multiply. And you put the result here. Okay, now in long division, that's kind of the step you would subtract. But in synthetic division, because you change the minus 1 to a plus 1, you add, right? So this is an add. Negative 20 plus 12, negative 8. Okay, then you repeat. 1 times negative 8 is negative 8. Put the result there. Add. Negative 7 plus negative 8 is negative 15. Okay, one more time. 1 times negative 15 is negative 15. Put the result there. Add. And you get 0. So when you that last number there, that's the remainder. Now this was the first problem we did, and it had a remainder of 0. So again, we still have a remainder of 0. These numbers here, right, the numbers that are to the left of the remainder, they are going to be the coefficients of a polynomial of 1 less degree than what you started with. Right? We started with an x to the third, so this has got to be a quadratic x squared. 12x squared minus 8x minus 15. Right, because so that since that was a 3, that's a 2. Right, 1 less. And the remainder is 0. The first time through, takes a little bit of looking at. Once you get going with this, it goes fast. Much, much faster than long division. And probably less chances to make mistakes. The problem is you can't always use it. Yeah?
Why can't you always use this?
You can only use this if you're dividing with a simple linear factor. If it's 1x plus or minus a number, you can use it. If it was 2x divided by 2x plus 1, can't use it. It won't work. Or if it's x squared, you're dividing by x squared plus 1. Won't work. So you can only use it in a really particular case. But the truth is that that's really what we need to do most of the time anyways. Most of the time, we're going to, in next class, we'll learn how do you find the first 0. And then once you find it, you do synthetic division. Because if the 0, whatever the 0 is, the factor is x minus that number. So you can use synthetic division to divide it out and reduce the polynomial. So that's what we do. I'm going to show you examples of the ones we can use and the ones we can't. So I'm going to do this again. Maybe I'll do the one on the right and you can do the one on the left. So I'm going to set it up, synthetic division, and then do it. Right? So the coefficients are 1, -1, -22, +40. All right, in the bracket, since I'm dividing by x minus 4, I'm going to put a +4, and I'm going to draw a line, leaving a room for a row of numbers, and I bring the 1, the first coefficient, below the line. To me, all of that there is just setup. You haven't started anything yet, you're just setting the thing up so that you can go through the process. Okay, now 4 times 1, I'm not going to draw all the arrows because it gets it so mucked up. 4 times 1 is 4, add. 4 times 3 is 12, add. 4 times -10 is -40, add, 0. So remainder is 0, x squared minus, or plus 3x minus 10. And isn't that what you got when you did the long division of those two? So you have to say that it goes a lot faster. Once you've got it set up, it goes really quickly. So try to do the same thing with the one on the left. That was the one that I did and showed you. See if you can get that. So should it look like 1, -6, 5, and 12. Put a 4 in the bracket. Bring a 1 below the line. 4 times 1, 4 times -2, 4 times -3, 0. X squared minus 2x minus 3. Clear as mud? Yeah. Let's see. Was that the same problem? No. Okay. So now I'm going to do I'll do the one on the right and you can do the one on the left. And I think the purpose of these two, as I remember, is just you don't always get a remainder of 0, right? I was just giving you problems where it was going to work out, but you don't always get that. So if I do the one on the right, I'm going to get 4, 1, -3, 7. and put a 1 in the bracket, bring down a 4. Does it look like I have it all set up? And now multiply. 1 times 4, 5. 1 times 5, 2. 1 times 2, 9. Right? Does that look right? Right? So now what does that last row of numbers mean? It means 4x squared plus 5x plus 2 plus the remainder 9 over x minus 1. So try to do the one on the left. Did you get that? 2x squared minus 5x plus 7. And the remainder was negative 16. So you say plus negative 16 divided by 11. Okay, I'm going to explain this now. So there is a theorem, which is called remainder theorem, which tells you that if f of x equals the dividend, the thing that was underneath, then if you do synthetic division with the number there, in this case negative 3, then f of negative 3 is whatever the remainder is. So if you want to evaluate a polynomial function really easily, then you do synthetic division. Just write down your coefficients, put whatever value that you're trying to evaluate the function at, and that remainder, that's it. Like this one over here, because we use 1, you don't change it. Like if I want to find f of 1, I don't make it negative 1 like this where I change it. No, f of 1 is 1. There's a couple sections in this chapter which we didn't do yet. I'm not sure how we'll get to them, but it's where you graph polynomials, and they actually use synthetic division to make a table of values. There was a few sections before they actually explained synthetic division, but they still use it. Caitlin?
So it was like the answer to the theorem, or to what we got before?
In this case, we're just trying to divide. This was the answer. I'm not going to give you one where we use the remainder theorem, but I'm just telling you what it is. It's in there. Okay. So let's see, what's next? Okay, so here's an example of a case where you can't use synthetic division to do this problem because it's not a linear factor. You can only do it if it's a linear factor. So if you have a problem like this, you're going to have to do long division. No other way around it. All right, so let me do it. 3x to the 4th minus 5. Oh, actually there was two things I wanted to show you about this. 5x to the 3rd. Notice that there is missing a power of the variable, right? And now you can keep that totally straight, but understand that we are going to be lining up terms, like terms, so that we can add and subtract them. And if you're not careful, if you just go from negative 5x to the 3rd to 4x, what happens if you make a square term? What are you going to add it against? I mean, it could get confusing. So usually what we do in a problem like this is we fill in, put a plus 0x squared, just as a placeholder. Just so if you make an x squared term, you've got something to add or subtract against. Okay. So it'll look like plus 0x squared plus 4x minus 6. Okay, so this is because missing yes. Okay, and now I'm dividing by x squared minus 3x plus 5. Right, what do I multiply times x squared to get 3x to the 4th? 3x squared. Okay, now I'm going to have to distribute 3 times this multiplication, right? 3x to the 4th. Peter. Minus 9x to the 3rd. And plus 15x squared. Subtract. What's 0x squared minus 15x squared? Negative 15x squared. Okay, then we're still going to have to go one more to the left. What's negative 5x to the 3rd minus negative 9x to the 3rd? Incorrect. Negative 5 minus negative 9. Positive 4. 4x to the 3rd. Now I've got to bring down the 3x to the 4th cancel, of course. Now I've got to bring down a 4x. How many times does x squared go into 4x to the 3rd? 4x, so that's a plus 4x. And that'll give us 4x to the 3rd minus 12x squared plus 20x. Subtract. 4x minus 20x. Negative 16x. Negative 15x squared minus negative 12x squared. Negative 3x squared. And then bring down the minus 6. How many times x squared go into negative 3x squared? Minus 3. So that'll be negative 3x squared. Negative 3 times negative 3x is positive 9x. Negative 3 times 5 is minus 15. Subtract. Negative 6 minus negative 15. Nine. Negative 16 minus 9. Negative 25x. And done. So you would say the answer is this, right? But you have to add the remainder, negative 25x plus 9 divided by x squared minus 3x plus 5. And when you get into calculus, if you have to take an integral, which we call integral, of this fraction, you have to x divided by that. You can't do it. You would have to do this long division first. And then in this format, you can deal with these terms easily. And then you've got methods to figure out things like this. But you wouldn't be able to deal with it if it was just a fraction given to you, an improper fraction. You've got to do the long division first. So this is the thing that comes up. You're not done with it. Now, this would be an example of, you can't do synthetic division on this either, at least not how it's written, right? Because you can only divide with synthetic division if you have a simple linear factor, meaning it's 1x. But you could change that. How could you make that a 1x instead of a 2x? divide it by 2, right? But if you divide the denominator by 2 to make a 1x, you've got to divide the numerator by 2, right? You may say, well, I think I'll just do long division. Yeah, and a long division will work, just like it is. But you could have done this. You could go divide by 2, divide by 2. And now we have x squared plus 5 halves x minus 3 halves divided by x minus 1 half. And yeah, there's fractions involved. And the truth is, you can use synthetic division to divide out rational zeros. And rational zeros are fractions sometimes. That'll happen. So here we go. 1, 5 halves, negative 3 halves. Okay, what number goes in the bracket? Positive 1 half, right? Bring down the 1. 1 half times 1. Add. 1 half times 3. 3 halves. Add. Okay, so the remainder is 0, so clearly x minus a half was a factor. What does these represent? But what is it? Say again? X plus 3, right? If we started with a squared here, we would get a polynomial 1 less power, and that would make it an x. So x plus 3. And I think I got what I have left. Okay, trying to remember this. Okay, so can I use synthetic division with this one? No, I can't use synthetic division. The reason that I put this one up, because I've seen this be like a problem we make mistakes on, is that if you notice what you're dividing by, that's missing a power of the variable. So even if that happens, you need to fill it in with a 0x to make it look like 7x to the third plus 11x squared plus 7x plus 5. And on the outside, I'm going to put x squared plus 0x plus 1. So fill in missing powers of the variable inside or outside. And then just go through the process. 7x to the third plus 0x squared plus 7x. Subtract. That's 0x, 11x squared. Bring down a 5. And now we need a plus 11. 11x squared plus 0x plus 11. Negative 6. I think the last two are homework problems. But I put them in there because I anticipate that if I don't do one with those directions in front of you, you may look at the directions and not understand what they're asking you to do. Right, this is the first one. It says, given a polynomial function and the factor of it, factor it completely. So notice here's the polynomial, and here's the linear factor of it. You're supposed to divide it out. Okay? And then if there's something more you can do to factor, then you do. Now, how would we like to divide that one out? Would you like to do long division or synthetic division? Synthetic, so like this. Go ahead and set it up. It's your homework problem. 1, negative 10, 19, and 30. What number do I put in the bracket? Positive 6, right? Bring down a 1. 6 times 1 is 6. 6 times negative 4 is negative 24. 6 times negative 5 is negative 30. What if you don't get a 0? Well, given the fact that they said that it was a factor, you better go back and check your work because it should be a remainder of 0. Right? They said it was a factor, so the remainder should have been 0. Okay, now what's left? X squared minus 4x minus 5. How does that factor? The factors of negative 5 that add up to negative 4. Not rocket surgery, right? What is it? Abdo. X minus 5, x plus 1. And the complete factoring would be those two and then the x minus 6. Remember when we multiplied polynomials? That's the kind of thing. You could FOIL all that and get it back. So if you're asked for, here's a polynomial and here's one factor, find the other factors, that's what the result is, something like that. The next set of problems, it says, here's a polynomial, here's one of the zeros, find the other zeros. Okay?
So you just make it x, no, x plus 3.
Well, how are we going to do it? Synthetic? So if we do it with synthetic, since they gave us the 0, they didn't give us a linear factor, they gave us the 0, then, you know, what goes in the bracket to the left is going to be negative 3. And the coefficients are 1, negative 2, negative 21, negative 18. Draw your line, bring down a 1, negative 3, negative 5, 15, negative 6, 18, and 0. So this is x squared minus 5x minus 6. How does it factor? Okay, but they didn't ask for that. They asked for the zeros. So what are the zeros here? 6 and negative 1. And then the third 0 was the negative 3. There you go. So when you get to those problems, you've actually done the first problem in each set. And that's how you're supposed to do them. Okay, what are the mistakes? What mistake did they do on the left? Yeah, they took all 4 of these like they were coefficients of a polynomial, right? And that's not right. That's the remainder. And these are the coefficients of a polynomial, which is 1 less than that. So it should have been x squared plus 2x minus 1, remainder 1. Okay? And this is the same problem. So what's wrong in the setup here compared with here? And this was missing a power of x, right? There was no x squared. So they did this correctly. Like they put a 0, that was x to the third and x squared. But this one they didn't put a 0. So you're going to be wrong. Right? That is that. So the next class, we're going to take a quiz. It'll be the add, subtract, multiply, and then the things we had homework on last night.